Hello, everyone. Welcome to Monte Jade West, AI at our doorstep, demystifying AI, autonomous cars, and humanoid bots, a talk by Brian Wang. Thank you so much for joining us wherever you are in the world. I am personally in Asia, so it's very early in the morning, Saturday morning. So thank you for joining if you're in Asia and also in Europe. I think there are some attendees and also in the United States. Thank you for joining us and spending your precious Friday afternoon with us. So I just would like to start with some housekeeping. First of all, this will be a webinar format, which means all of you will be muted at this time until Brian finishes talk, which will last about 30 to 40 minutes. In terms of Q&A, please use the chat feature. And we actually will call upon you, and assuming you enter your name when you enter this call, we will call upon you for you to post the question yourself directly to Brian. And at that point, please unmute yourself. And last but not least, please enjoy the session. So a little bit about Monte Jade. So my name is Nana Tang. I am the chairwoman of Monte Jade. Monte Jade is actually named after the highest mountain in Taiwan. And it was founded in 1989 by a group of Chinese American entrepreneurs and also businessmen who came to the United States in the Silicon Valley and were looking to support each other in building a community. The purpose is really to provide a opportunity for cross-border collaboration in investment and technology opportunities, for the exchange of technology and information, and as well as to build a community that will enable mentorship and to build the future leaders in the Silicon Valley. So through events like this, we aim to really build a platform for networking and to really promote and encourage the sharing of valuable experiences in entrepreneurship, in investment, in technology, and business management. So so next page, please, Helen. And this is just to share with you some of our very notable founding members. If any of you read Chinese, one of our founding member is actually Terry Guo. And many of them on here, like Terry, have become very successful businessmen in both the United States as well as in other parts of Asia. Next page. And one of the program that we really would like to promote and we're very proud of is the MJAA mentorship program. This program has been running for more than 20 years now and has members, as you can see, the mentees from companies that are illustrated here. And the mentorship program is now open for application, and we are capping it at 60 mentees. So it's a great program that I would encourage any of you who are interested to apply and refer to the website link mentioned here below. In addition to the mentorship program, we also have an executive membership program. This is a new program, and it will be a by invitation program. And for further details, please also email us at executivemembership@montejade.org. And finally, very importantly, we would not be able to provide these type of events without our kind and generous sponsors. So there are many levels of sponsorship that's available. And I would definitely encourage any of you who are interested to apply or to sponsor us to get in touch with us, and we'll be happy to work with you. And now, without further ado, I'd like to bring Brian Wang, our speaker for today, onto the webinar.
Hello, everyone. Let me just get my slides up. Okay. NVIDIA CEO Jensen Huang said within the next 10 years, he hopes AI will accelerate, they'll accelerate AI models by another 1,000,000 times. So that is a huge transformation. And today I will talk about what you otherwise would not hear or understand about AI, things that are difficult to summarize, find, or properly analyze. There's a lot more AI at our doorstep than people realize, and I will demystify and let you know what that's about. So, introduce myself. I'm Brian Wang, a leading futurist, business science and technology analyst, also an investor, corporate advisor, and fundraiser. I've written over 30,000 articles and spoken directly to many thousands of the scientists and business leaders creating the products and technology industries that are changing the world. I've dove deep into thousands of research papers, business plans, annual reports, earnings calls, interviews, conferences, and presentations. All this information has let me get a pulse of the leading edge of technology. And I know where it is and where it could go and how it got there. So I can then figure out what matters, how do things connect, what does it mean, where are things going, what will happen, and what to do. So today's talk, I'm going to start with why robotaxi and humanoid robots are together. So that's something people may ask, like why am I first talking about robotaxi, human robot, and along with AI? So first, we need to understand why large language models have had the large impact they've had. So they have enabled internet scale and beyond. Previously, we could not get nearly that much data into an AI, and now we can put the entire AI into GPT-4 and the competing models. And we can go beyond that scale. The models keep getting better with more data. We also have conversation and understanding with the systems where we can talk to it or write out text that is in our normal conversational method versus some kind of like obscure computer language. And these systems are very robust, and they're also changing. Where they started as text, they've gone to sound, images, and video, and also to robotaxi and humanoid robots, as I'll explain here. So Tesla had created and applied the systems for large language models into a language of lanes. So they can, instead of having letters that form words into text, they would say, take the lane position and then add it to a sequence of lane positions and turns into a language of lanes and traffic. Also for humanoid bots, others have created a large behavioral model where actions such as moving your hand, reaching out, taking a step are built up into a series of movements that can become building a car, performing a dance. So the component elements of movement go to robot control. And we'll discuss them more deeply. But basically, the technologies are common between large language models for AI, large behavior models, and the neural networks applied to robotaxi and self-driving cars. So now I'll dive deeply into the self-driving cars and those technologies. So people have a lot of misinformation about robotaxis and automated driving. It's not just technology. There's also what is happening with human driving at a large scale, and their intuition is wrong about safety and how things will switch over, and also the business models. So we can look at a Waymo car, Google's robotaxi company, which has a few hundred vehicles there. And you can see that there's a lot of sensors on the vehicle. And people would perceive that that is a good thing, which is not an unusual thing to think, because of the almost 40 companies that are doing robotaxi, pretty much all but Tesla were using the laser radar and other sensors for it. And the complex sensors work at different ranges. Unfortunately, this system is brittle and also has problems with its business model because each robotaxi would need 8 LiDAR, 8 radar, and ultrasonic sensors. If I need to make 1 million robotaxis, 2 million to get to Uber's scale at 7 million, you would need to have 16 million LiDAR, which we only made 200,000 auto-grade LiDAR in 2021. So there's problems with the business model. Also, some people know is that the leaders are in China for the robotaxi. They're doing the same thing as Waymo, but Apollo Go, which is a Baidu subsidiary, is actually ahead in terms of giving more rides. But all the leaders are often spending about $1 to $2 billion per year on the development and only making a few $1 million because they're only making $1 million per ride. So they're only doing a few hundred robotaxis each, the leaders, in a few cities. And people think, well, they removed the driver. That must mean that they're safer and better. Here is a remote driving center that Baidu has. So they've taken away the human driver out from behind the steering wheel, but they're remotely operating the vehicle. Cruise, which was considered number 2 to Waymo in the United States, before they were stopped from offering service in the US because they ran over a person, was having 1.5 remote drivers per vehicle. So actually more people were remotely operating the vehicle than were having behind the wheel. So they're going through this phase of supervised driving, either someone behind the wheel or someone remote. So going over the business models, you have Uber ride hailing, along with Didi ride hailing at large scale, 7 million vehicles for Uber, 20 million vehicles for Didi, which is the dominant one in China. And they have Waymo and the other classes of robotaxi companies, of which there are roughly 40 in the world, but most offering like 500 vehicles, although Apollo Go could go to 1,000 this year, or a couple thousand this year, and to 10,000. So again, China is ahead of Waymo. And then Tesla with 6.5 million cars, all of which are robotaxi capable if the software was able to do it, but they provide over-the-air updates. But they chose to spend about $10 billion, $1,500 per car, to get the cameras and the computer chip into all the vehicles, even if you did not buy the system. And Tesla is making billions of dollars already with their AI system because they offer autopilot, the driver assist, as well as FSD, the full self-driving system. And I'll talk about them more in detail. And their AI is very good. Here we see the 8 cameras of a real monitoring the environment, and then they can simulate frame by frame moving forward as you hypothetically drive down the road. So there's a lot of technology behind what Tesla is doing there. As I mentioned before, the leaders are not Waymo. Baidu has over triple the rides that Waymo does. But then in terms of the driving data, and data is very important for AI, Tesla was at floating at 1 billion. They're probably now at 2 billion autonomous driving miles versus a few, perhaps 10 million, 20 million for the competing companies. So something else to understand is for the safety, mistakes in cars are not fatal. This is for human, this is for automated systems. Only about 1 in 200 car crashes result in fatality. About 1 in 5 result in injury, because mostly offender benders. Most of us have had, some instances where we have slightly damaged our car, but we did not personally get injured. So that will also be true for the automated systems. But the system's are already safer than human in many cases. Autopilot is about 13 times safer as the driver assist system. If you have it turned on, you're 13 times safer, 10 times safer than if you don't turn it on. And the Tesla vehicles themselves are already passively safer than regular system cars. And the FSD is also safer in terms of miles per crash, but again, it's a supervised system. So in terms of an overall view of this, there's about 10 to 20 trillion miles that we drive. 3 trillion miles are being driven in the United States, 1.3 million deaths globally, about 40,000 in the United States, and then 20 to 50 million injuries from that, of which there are maybe 100 million some accidents. So there's a lot of accidents and humans are doing a bad job. And then there's various categories of where these accidents are coming. A third hitting pedestrians or bicyclists, and then a third on highway, a third related to speeding and stuff. So you can eliminate whole categories if you get rid of speeding and DUI. So Tesla FSD 12.5 has been spotted. Currently, people have either 12.3.6 if you have a Tesla or 12.4.3. 12.5 is another step up. And Tesla, because they've gotten to all neural net systems, they have a very high cadence of like every 2 months, they're releasing a major new system. And there's talk that it would, but from Elon Musk, that they would get perhaps 10 times better from like 12.4 to 12.5 to 12.6. So 12.4 would be 10 times better, 12.5, 100 times better, 12.6, 1,000 times better, something like that. Even at a lower amount, it's a huge amount. To contextualize that, a new teenage driver is 3 times more dangerous than a experienced average human driver. And then you have another step 3 times up to like a professional driver. So when we step up 10 times, 10 times, 10 times, or 5 times, 5 times, each of those steps would be bigger than the gap between teenage driver and regular driver. Now, if you're doing that every 3 months, the improvement would be very rapid. And we're going to come up to an October robotaxi day, date to be announced, pushed back from August, where Tesla is going to reveal their system. There have been experts who have looked at FSD, Tesla FSD versus Chinese competitors versus Waymo. And the consensus is that Tesla's system is superior to the Chinese systems, and the Chinese systems are often superior to Waymo, slightly. The Waymo and Chinese systems are about comparable to the version 11 system that Tesla had last year, but then Tesla has gone through a transformation going to their version 12 systems. I think also that robotaxi car companies could license the Tesla FSD if Tesla fully solves it, because the economic incentive for them to do that, getting something that actually works, will be very strong. But people could say, well, why would they use Tesla's technology? Why don't they try and develop their own? Almost all the companies are using NVIDIA chips and NVIDIA software, and then adding on top of that with other companies' LiDAR and sensors. So the company, the robotaxi or the car company, is usually not making their hardware software stack. So if they say, I switch from them to another provider, aka Tesla, instead of NVIDIA, it's not a huge deal. And again, something that people who are not paying close attention may not realize is that Tesla and their FSD system are getting a lot of support from the top levels of Chinese leadership, meaning Premier Li, the number 2 guy in China. And 12.5, so the question would be, will all the features be good or perfect? The expectation is that they will have reverse, which is one of the, on a list of like 40 items to check off, there's about these 6 or 7 things. Going to reverse is an important capability. Perfecting the summon, which is like call the car with your phone or app. Parking the car automatically. And then also dispatching, meaning you get out of the car in front of where you want to go, and then you send the car off to park itself. And they also should handle emergency vehicles better and flashing red lights. These are all also problems that have been happening with the regular robotaxi systems, where they've had a lot of instances of blocking traffic and having problems with emergency vehicles. And those other systems have also tended to be very brittle. Tesla SFD will also merge highways and city streets. This is important because the autopilot system, which is more hand-coded, was the system used for highways, but it was already at a level of 1 accident per 7.6 million miles, which is at 13 times better. So Tesla going to merge the city street driving with the highway means that their FSD system will be safer, significantly safer than the autopilot, perhaps up to 10 million miles or more of safety. So again, 15 times better. So what does this mean for the long term in terms of the financial impact? ARK Invest has indicated that in the 2030s, this could be, by replacing most of the miles driven with robotaxi, this could be $10 trillion in sales, which is obviously a huge amount. But what does that mean? You need 100 million to a billion robotaxis to provide those services. So there is a lot of capital expenditure and infrastructure that has to be built in order to do that. So not just making all that software solution and hardware solution and then deploying it, but then you have to scale up. You must make 100 million, a billion robotaxis. And then whatever your hardware components are for that, chips, cameras, other systems, that also has to scale. If you're using LiDAR, you would need to have like 8 billion LiDAR to get to a billion robotaxis. I believe that the China robotaxi companies, which are several, will be adopting the Tesla FSD systems. Hopefully we'll find that out in October, early next year. Again, Baidu Apollo is a leader. They were already talking about going to 5,000 to 10,000 robotaxis next year of their own. If they could get Tesla vehicles to do that, they could go to 100,000 or more. I think also that two of the other major companies, AutoX and Didi, would also be ones that would use Tesla system, assuming the solution comes as I expect. So to take away from robotaxi is this supervised phase of robotaxi is highly profitable. It's not profitable yet, but it can become highly profitable. And whether that is supervision in the car or remote, it is something that can be very useful. And there will be a transition from supervised now to unsupervised. And it could pass through several months or a year of wide deployment with both safety drivers and with remote drivers. And the system's already 10 times safer in many ways, the Tesla FSD system. Other ones are also safer, perhaps only 1 or 2 times safer. And another critical aspect is the business model, that the just giving out rides is not as good as selling the vehicles, but making large numbers of them. Having a small number of vehicles is not as good as having large scales of vehicles. And because the end goal is so large, getting $10 trillion and a billion robotaxis, supply chain partners and infrastructure are critical to get to that final situation. So now talking about humanoid robots. The humanoid robot opportunity is even larger than the $10 trillion robotaxi opportunity. Various estimates are 30 trillion, and that's before things change. That's more replacing what currently exists instead of building new markets. There's been about $20 billion invested by 20 to 30 companies. The two largest spenders, Unistream and Boston Dynamics, are not the leaders in that. They were the ones making more of those toy demo things that are interesting acrobatics, but not actually addressing a business opportunity. And so comparing that again to robotaxi, there's been about at least $150 billion spent on robotaxi. So robotaxi investments have been over a longer period of time and a bigger. But there is a transfer where things developed for robotaxi, like the data gathering systems, video analysis, are all transferable to the humanoid robot area. And the human robot area could take off sooner because there are many use cases that are not have no major safety component. So you can introduce a robot where it doesn't work perfectly, but would still be useful. Discussing a bit of the technology about that in more detail. NVIDIA is, as we saw in the original slide where Jensen was on stage with about 10 other human robots. NVIDIA is helping to enable simulations and also learning by copying humans, a motion capture kind of method. And they have their simulations working at 1,000 times the speed of normal reality. So again, many of the companies are choosing to partner and use and then build upon the NVIDIA technology. One key observation is, having spoken to several of the human and robot companies, is that it's only taking a day or two for a skill to be learned. There's many skills to learn, but the simulation and demonstration training systems are very effective for teaching the robots. In terms of the supply chain component aspect, the robots need actuators, about 30 to 100 actuators. In this case, they're talking about 40 electromechanical actuators in the Tesla bot. And the actuators that existed before, the things that move mechanically the parts of the robot, needed to be made new for the new class of products, because the previous versions were too heavy and did not fit the specifications that they need. So these early robot companies are needing to basically develop their own factories and vertically integrate and develop their actuators. Eventually, as the industry matures, you could have separate companies that specialize in actuators. And if you had 1 million robots, you would need to, again, make 40 million, 100 million actuators. So that is one of the key components of the unique components of this new industry. For people to get an understanding of how easy or difficult it is for these systems to work and become useful, there was a small project in Stanford called the Aloha Project, which we see the work here. The robot, you see, only has pincers for hands, so not actual fingers. They bought the pincer hands and arms off the shelf from a supplier. And then they trained it, basically 3 students. Their whole budget was less than $50,000. And they basically were graduate students, so they're not doing it full time when their job. It was their thesis project. And they were able to have the system cook shrimp by itself in a fully autonomous mode. Some of their training was done with a teleoperated method, basically someone behind operating joysticks to do the work, which shows that the tasks could be done with crude hardware, but also that it can be done fully automated. And they did many tasks, like cleaning a wine glass, a delicate wine glass, operating elevators, operating around the kitchen. So for people who think, well, it'd be so hard for a robot to develop and do these things, even a poorly funded project with 3 students, smart students, were able to achieve a lot of what we think would be useful in terms of a household robot. Well, how about the funded companies? Sanctuary AI is a company in Canada that's gotten about $140 million in funding. They have papers where they analyzed all over 1,000 human jobs. They decomposed the jobs into a series of 100 tasks, and those tasks into their subcomponent actions. So they have totally mapped out that space in their database of if we can do this alphabet of actions, reaching, grasping, pointing, then we can build that up into all the tasks, the skills that become the jobs to replace all human labor. Of course, saying that, mapping it out versus actually doing it, the huge thing, but the detailed plan going from the letters and language of movement to full job replacement is something that has been mapped out. In terms of mass production, Agility Robotics, one of the competitors, is going to make about a factory, is making factory right now that will make 10,000 of their robots per year. And then others are also scaling up. Of course, Tesla with their Tesla bot already has Tesla bots in Tesla factories. Only a handful, but they are already there doing some useful work. Here you see one moving the simulated 4680 battery that's in the Cybertrucks. And Elon has mentioned just a few days ago that there's a new robot design. They've already gone through about 4 iterations, and this will be Optimus number 3, which will be complete later this year. And he says it's going to be special. But the difference between, so in terms of like figuring out who's going to win, like all this technology is complicated. Just like the robotaxi, it's difficult to understand who's going to win, who's get to scale. In this case, I think all of them could get, if they execute right, can get a viable market, because human labor is this $30 trillion thing. There are a range of human labor from, someone earning $1 an hour someplace in an undeveloped world to high-skilled labor at $50 or $100 an hour. There's a range of what a robot could be developed to do. And there's many, many opportunities to build a business. Moving boxes is by itself just a very large market, and there's plenty of demos showing these robots moving boxes. But in terms of a major economic advantage, is that Tesla will use them for their own factories. And Tesla can change, and is planning to change their factories to be bot-centric. They're going to entirely change the 100-year-old method of manufacturing a car from, on the left, building the frame of a car, into what's called the unbox process, but is perhaps easier to understand as building the car out of large Legos, right? Where I can build 10 large Lego pieces together and have 4 bots, 4 humans, and then 4 bots surrounding the module, and then snapping the 10 pieces together at the end of the line. So that is obviously faster, 10 parallel processes. I can start from the beginning of the factory, move through 10 parallel processes, complete in, say, an hour, 2 hours max, and then get the car at the end. Versus today, starting at the beginning of the factory line and then taking 10 to 20 hours to get to the end. It can be 10 times faster. And it'd be a process made robot friendly. And the economic value would be that they could replace expensive labor, but they can also increase the speed of production. If I can get that 5-10x speed up in production, Tesla goes from making 2 million cars, if they go 10 times faster, to 20 million cars in a year, which would 10x their value from just short of $1 trillion now up to $10 trillion. And that would just be from replacing or enhancing 150,000 factory workers now with 300,000 robots. The value from creating 10 million, 100 million robots, 1 billion robots, would be even higher than that. Just to understand where the other robots are, the orange robots are pallet bots at Amazon. They have 1 million of these robots. They redesign their warehouse system when they fulfill a order for us. When we order 5 things from Amazon, they would then have these robots bring shelves to the people so that they could grab off the shelf the 5 objects, and then the shelves go back. So these moving shelf things of designing your processes to work with the automation. You also see this at Costco, where they use forklifts as a central part of what they're doing. When you redesign, as opposed to doing things as we've always done it, you can get huge gains. So Tesla will see that for the factory. Amazon has seen that for warehouses and supply chain. And Costco has saw that, with just humans working at their retail outlet. And this is the agility robot also in Amazon's factory warehouses, moving boxes. And this is Figure AI, which has funding from OpenAI and Microsoft and Amazon and others working on their in Amazon's warehouses as well. So who has humanoid bot pilots? There's Tesla, of course. We mentioned Amazon. Sanctuary AI is working with Magna, which is a auto parts company. And then there's Figure AI, I think, is working with BMW. And Sanctuary AI is working with Canadian Tire retail store in Canada. So there are also different uses for the humanoid robots beyond just the manual labor type things that people more often think of. Famous robots in fiction, of course, C-3PO and R2-D2. So if you think of C-3PO, he was able to converse smoothly with Luke Skywalker and the other people. But he also had a lot of data. He could answer questions, like what's happening, analyze something. And then R2-D2 had even more information and access to information. And this is something that we're finding that we want from interacting with the large language models. So there's the training, which people know now, the data centers are training the AI to learn to do things. But then the larger market will eventually become using the AI to give answers or using the AI to drive actions. NVIDIA claims that their H200 chip can generate 7 times the revenue that they cost, and the cost is high, about $40,000 per chip. And then you have to add on energy and other things to use it in over 4 years by running the Meta Llama 3 open source model. So this would mean that you could replace, Google search in some cases to answer questions directly. And people know that, Google search is not quite as good as AI because AI gives you the full answer. And when you go to a chatbot, we give you the right answer. Versus Google search, you're getting a list of links and they have to still find what you're looking for. There's still not a complete answer there. And comparing the economics of it, we can see that on the left, that Google is about 15 times more profitable than its cost. Previously, a few months ago, the large language models were 1 to 10 times as expensive as the money they're earning. But with the NVIDIA chip, we could get to a profitable situation, highly profitable situation for the large language models. So then it becomes, this is also a detailed analysis, don't need to look at it in detail. Just the highlight is that adding up the costs of the electricity and the co-location, we're looking at $2,500 per month, not including the capital cost of the chip. So we're looking at $30,000 per year. And then if we're using 8 or 10 chips, 8 chips together, we're looking at $150,000 per year. So the costs are very substantial for that. Here I projected forward on those data centers. We can see that we're right now at the GPT-5 level. People are trying to build GPT-5 systems, and we're at 100 megawatts for the energy, for the number of compute that we have. It is very difficult to go beyond that, although we are, because under a normal situation, just putting a new data center with a 100 megawatt draw into any state, you can bring down the grid, which is what Microsoft found when they're trying to build their larger data centers. So there is a lot of problems scaling the energy and compute in one location. So if it's difficult to put all that in one location, the answer is to distribute more of it, because I need to have even more inference computing, answer generating compute. I need to spread that around. So this goes to what would be the value of having many Tesla bots and many Tesla cars that have these chips inside. Each of them will have AI5 chips, which will be introduced later next year, that will be highly competitive for doing inference compute. They could generate about $5,000 per year for Tesla and for the owner of the bot. The bot itself could cost $10,000 to $20,000. So an owner at a home could generate money even if it wasn't doing household chores, gardening, or other tasks, just from being a better way to deliver the large language model answers. Comparing the chips to our laptops, the chips will be 20 to 200 times more compute than the laptops. They would also draw about 20 times more energy. But if you have your solar power in your roof, you would be able to power it. And they would be using about 20 times less energy than if you had an electric car. So it's in that, it's something that would be useful to deploy. And I think this would be a key use case revenue stream that will enable millions of these robots to go out perhaps as early as 2026, 2027. And it's less of an energy problem to solve the inference issue of how do I get even better large language model AI. And it could be, again, 10 to 100 times the data center market, which is already a huge market. So now I'm going to the big picture of regular AI, not embodied bots or cars. And this first topic is there an AI bubble, and are we hitting limits of AI? So for the AI bubble argument, there is that we're spending about $400 billion for AI in 2024, the companies, Microsoft, Meta, all the companies combined, spending $400 billion. $100 billion of that is AI chips. So $400 billion, the question is, what return do you get on that massive capital spend? Because we're clearly not making that money back yet. But the Silicon Valley VCs and companies, big tech companies, are willing to bet on that because they believe that it will come. And I'm going to give information about how I think that could happen. Also, the spending in 1 year is not everything. There's also projections that the spending will increase to $2 trillion by 2030 for the AI data centers, up from those hundreds of billions that are AI related now. And then the large language models will hopefully generate the $14 trillion of revenue from that. Part of that we're spending, like there'll be two sides, people spending that and then people providing it. Some of the large language models that matter are the Claude 3. These are very familiar with everyone, so I won't dwell on this. And then the companies, two of the other startup companies that matter are Anthropic and Perplexity. Anthropic is supplying the Claude 3.5 Sonnet, and Perplexity, they're both current leaders in many ways in terms of the current models. But who's leading and who's not could change month by month. So why do I think that the AI will keep improving? Andre Karpathy, who was the head of Tesla AI, he says that the current models are undertrained by 100 to 1,000 times. This is based upon research by Google into something called the chinchilla point, that basically if you train it up so much, you get to an optimal model performance. So they are stopping the training 1,000 times early in terms of how much compute they've done because of the limitations on resources and cost. They're just choosing, I've trained it up, it's still getting better, but I need to stop. I spent 3 months on it. I'm going to now work on the next model. And I'm going to push this other one out to users so I can keep going and keep developing. But if things start to slow down, they would train closer to the point that they know they would keep getting more value out of doing it. So that means that, get 10 times better chips. Instead of spending 3 months, I spend a year, and I, improve my compute levels by 100 times, and I would get they know from their research that they would get a clearly better model, even without improving architecture, data, other aspects of it. They know they would get a better model. So there's plenty of headroom in what we're doing very, very efficiently. The other reason is that OpenAI, a lot of rumors around that they had something called Q-Star, now possibly called Strawberry, which is a reasoning breakthrough, that they can get far better, more intelligent systems on the reasoning side. Still be determined, but that may have been why there was the drama of Sam Altman getting fired and then getting hired back, and the power struggle that was happening there, because of the breakthrough in the reasoning level. The other side of that OpenAI battle was Ilya Sutskever, who has made huge advances with convolutional neural networks. Made the basic advances, had done it. Is also integral to making OpenAI what it is today. He has now started a new company, Safe Superintelligence, but he has said that superintelligence is, he has it in sight. He didn't give a time on it, but he seems to indicate it's close. So we're again looking in the range of 2 to 7 years, right? Between 2025 and 2030 is roughly when we're looking at major advances towards superintelligence, which is intelligence beyond all normal human capability. Another basic model improvement is Microsoft has created 1-bit models. So instead of several bytes to hold a piece of AI information, it only takes 1 bit. So this reduces the size, memory needed, as well as reducing the energy requirements for the models. So this is just 4 small snapshots of a lot of development work that shows that there's a lot of advancements to be made. So those who say that we're going to cap out, it's just because there's been a delay in GPT-5 coming out, does not mean that we're not making the improvements. On the hardware side, there's TSMC, other announcements from the other Taiwanese companies, other chip companies, about improving the power of the AI chips by about 40 times. I'm not going to have time to discuss that in detail, but the software and the hardware are still drastically improving, and will also solve the shortage of NVIDIA AI chips. They're looking to remove the interposer, which is one of the limitations, and there's also other reconfiguring of the hardware and also of the production process of the wafers to get to the higher volumes that they need. There was an announcement recently they would go from the 12-inch wafers to a rectangular wafer that have 3 times the area, and also would have less wastage. So huge efforts being made to satisfy the demand. Also, on the money spending side, we have the $10 billion spent by Meta and many other companies this year. And then starting next year, we're heading towards $100 billion for major data centers. 2 major ones that are known are the Microsoft OpenAI data center called Stargate, and Kuwait is also developing a $100 billion data center. So now discuss the 4 major categories of known product areas, applications for AI. So we are basically replacing Google search in many cases. I think anyone who uses it knows that you're using Google less because you're using ChatGPT or Claude Sonnet or one of the other systems to answer your question. Google makes about $100 billion per year from their search. And this projection is by Altimeter Capital, a $10 billion fund, that they expect the crossover between AI search and Google searches to happen within a few years, by 2028 to 2030. Programming is another huge application. Microsoft Copilot, a lot of evidence that makes programming more productive. And I've personally seen that. I've talked with people in Silicon Valley who have used the programming tools and the AI tools to help the programming. They lead teams as, give better code. It still takes some work, but it gives better documentation. So there's a lot of value that people receive. If not perfectly there, there's a lot of issues to get it refined. But the general feeling is that these issues will be very well resolved over the next year or two. In terms of the rate of improvement of the programming, here's an analysis of GPT 3.5 versus 4, how GPT 3.5 went from 48% on passing a coding benchmark to 67%. So it's a substantial jump up, nearly twice as good over the a year between the models. However, here we see that there are models that can get, or enhancement to models that enable getting up to 95%. This has already happened. And it's because the previous 48%, 67% was based on what's called zero shot work conditions. So basically, it's just starting to write directly. It's like I'm trying to write, War and Peace, and I just start writing and don't stop and don't correct. But here, if you write it once and then you reflect on it, see if there's mistakes in it, review it, try a few more times, fix it, taking that time instead of taking 1 minute to just do it all in one blast. They may take 30 minutes, a half an hour, which is still fast to do the code and getting far more accurate results. This is called agentic workflow, where you loop around and make sure that things are corrected. So one, you can get there by making the models big and better, and they can do it all right in one shot. Two, you can have the same models get a better result by having them work and test the work that they're doing. So then if you can master software, get it 10 times more productive, and also improve the services that people give for computer software or hardware, that is a $2.5 trillion market today. So that again could justify the $400 billion spending this year and adding up to trillions of dollars in spend if you can provide value and grow this market, make more productivity there. There's also business productivity beyond programmers. There's other people in the company. So the business people, what's happening there? So this year, there's about $5 billion being spent on what is called enterprise AI. This was information from Andreessen Horowitz, another VC company. And what are they spending the money on? One of them is a Glean Enterprise. So this is a work productivity tool. Their valuation of the company is $2.2 billion. They have a few hundred people. What they allow is basically search within your company of the unstructured data that you have. So data sources like Slack, your project work plans, your PowerPoints, your Word docs, all these other tools and software products that contain the work data that we have in our businesses. So they were able to search that, and then they were able to get many hours saved for, say, onboarding someone onto a project. A 20% improvement in it takes time, people new hired to get on board using Glean, and they're talking about 17 times return on investment from that. So that's some examples of that, where you're just by getting a kind of better search, but business-related search, you can get better results. Another example is AI Tomatic. They do industrial AI. So they apply large language models to industrial situations. So if I have a workman who's going to look at some telecom software or a factory machine, that person may need to look up the user manual to understand what's going on with that system. They may not know what some frequency is, some other testing procedures. All that information can be provided by an industrial virtual advisor that these can provide. And this system works for semiconductor situations as well. They have a digital ASIC product advisor, and they have already found that it boosts, performance by, time to get results by 15%, other, faster and cheaper, less downtime, all those kinds of good improvements. More broadly than those products is what happens next. So we're in this, this is a presentation by James Fan, one of the technological leaders at NVIDIA. And he's describing what he calls the agentic era. So right now we have prompting and the system has to be supervised. If we can get the systems to plan and help improve the decisions, which is something we discussed in that agentic workforce, planning how to solve the problem the best way. Applying that more broadly in the business context is also something that will have huge value. So the system will go to being agents where you don't just ask it and get an answer. You can also have it go off and do things that you permit it to do. You say, okay, I broadly give you permission to manage and monitor and act upon certain aspects of my financial portfolio or other things. So this is an area that is, much more complicated, but agents is AI going to do things for you, either virtually or in reality. So what will working with these agents be like? You could think that it would be an impersonal experience. I don't think that's going to be the case. Microsoft has created VASA 1. They haven't released it yet. They still want to hold it back to work on certain safety aspects. But if you give it one picture of yourself or someone else, an audio clip of the person, this will then, within seconds, fraction of a second, start generating perfect video images of that person talking. And it would have emotion, the right eye angles. It's not like just animating the mouth, it's animating the whole face. It's basically like when you watched the movie Terminator, where the Terminator heard someone talking on the phone, like the recording of the voice, like the mother-in-law, and then it instantly started mimicking that voice. That's what we'll have with that. So the agents will be doing stuff for you, and it will look like us. I think doing the deep fake type thing of like pretending to be another person will be less a thing than actually having it represent myself. This whole talk could be done where I put in my text script into VASA 1, and then it could be presented to you, but with the right amount of pauses, no ums and ahs. It would be a perfect presentation of myself. And I could also give it a picture of myself when I'm 25 years old. So then it could look and sound like I did 25 years ago. And it also works for like putting the Mona Lisa in there, animating that, other things. So it doesn't have to just be realistic images. It can be these kind of cartoon or other images, but it has emotions and expressions to it. So I'll give some key takeaways before the Q&A. So there will be market crashes. Most of the projects will not pan out. So it'll be huge losses. But the overall industry will have large profits we made. And I think business, IT, our life will change substantially with what is happening. And the agents that we'll have will be digital and physical. Those are the next things that will have a major impact. And the even more world-changing aspect of superintelligence, I think, is possible. So what do we do? So one, understand the more AI is already here, and we need to keep on top of it. So we have to learn and keep up with the change and adapt to it, embrace it, adapt it, and use as much as we can. Whoever uses it more will be a winner. and you can get help on this, and I'm available for that. If you think that has value, where I can do a deeper dive with you, I can be engaged for consulting it and to advise people or to give a more in-depth presentation on a particular aspect to drill down into what we're talking about here. So again, today's talk was about robotaxi humanoid bots, self-driving bots, humanoid bots, and the big picture of AI. So thank you, and you can contact me here, also through Monte Jade, and that will work for any questions. Oh, you want the links again? Yes, sure. I'll put that back up again. We can also make this deck available to people if they want to sign up, give contact information, email addresses. We can get that out to you. I think that we want to engage more. We will have a talk in 3 months. Looks like we have someone with their hand up. I will. We can try and unmute Alan Ng. He can maybe speak out his question when he's unmuted.
Hi, Brian. Alan Ng here, Northeastern University, Silicon Valley. Thanks so much.
Yeah.
I posted a question in the Q&A. I was wondering what you felt were the biggest obstacles for enterprise AI adoption for things like AI assistants and chatbots. So I know Glean was one example you shared in your presentation.
Yeah.
But other types of, there are many other startups that are doing enterprise like chatbots to do search and GPT work for, let's say, their own domain of assets, documents and PDFs and research and information. But what do you feel is the biggest adoption within enterprise customers to adopt that and deploy them?
So what I've seen going to generative AI conferences is that companies have started piloting different solutions, whether it's your Glean or just using the chatbots. Deloitte has bought 100,000 OpenAI GPT-4 licenses, and paying the $20 a month for that, and they're trying to integrate it into their processes. So right now we have an exploration phase, but companies are trying to productionize and go live with it. So there's the learning to understand the reliability, because many things are not fully reliable at this point. So it's whether the solution is ready for prime time is an issue. I think it's going to get there, but it's like hallucinations, unreliability, that certain things may work sometimes but not others. So you have to introduce in a situation where you can get the benefit, but like make sure that it's actually doing what you want. So that validation phase is learning what it actually does, learning how to use it productively, and then validating that it's good, and then making the correct process changes.
Yeah, just a quick follow-up question on that is, how would they measure the validation and credibility of the responses? I understand there's hallucinations, but how would you measure it for that to make sure that they could trust the responses? So I understand exactly what you're saying. How do you actually measure that?
And, it's case by case in terms of like what you're trying to use it for. So, you would have to fully understand the use case, whether it's customer service or something else, so that you would say, okay, I'm measuring my customer service humans by saying, okay, how fast can it process the get the answers to the person, and then how satisfied they are with that answer. You would use your same metrics on the uh, digital customer service solution that you have to test it against it. So it'd be like if I was going to replace my um, Philadelphia uh, call center team with a team from the Philippines, right? Presumably, you would, try them out in parallel for a while, have measurements around one group, determine the measurements in another group, and decide, okay, now it's good enough. Same thing, I was going to go to a digital version of that, or to, like switch vendors on the digital side, you would, analyze it in detail, what's being done, and if it meets the standard, and do it. Oftentimes, you may need to, in the current situation, have it work on things that are more precise and less nebulous, right? That measurement problem could mean that you can't trust it to do something that is more personal touch kind of thing, right? But like, for example, if I say write whatever some code, if you say, give instructions to do it, but say write a Python program that does it, then that Python code or the SQL code would be fully something that you could validate, right? I could run it. It doesn't work. It works if it runs and gives me the right answer. If it doesn't work, so it's a very clear black and white kind of situation in that regard. So those kinds of black and white, it works or doesn't work, doesn't have the validation problem.
Right.
If you have something that involves a lot more testing, then, like right now, an example was that we thought that the software AI systems could beat us in the game of Go, and they beat the world champion. Okay, it's better. Then they applied an adversarial software system to find weaknesses in the AI Go systems, and then they found that it couldn't handle a ladder attack kind of thing, where you basically start going up and keep going side by side, two structures. It couldn't see that. In the sea of statistical stuff, it couldn't see that, and it couldn't fix itself even after months of that being identified as a problem. So that goes to automated testing is needed, because we're dealing with something that's so complicated. We will often need to have automated testing, and then, but still, at some point, it goes back to the person, right? That someone has to be responsible for these systems. Claude and Anthropic are trying to do more automated testing of their large language model. So there is a lot of like, computers testing computers kind of thing in order to make sure that it's working. But it is a non-trivial problem to work that out.
Thank you so much.
You're welcome. We have, I think, someone else, some other people raise their hands.
Yeah, it's me.
Okay.
Hey, Brian.
Hey.
Hey, how are you? It's great to hear you talk again. Thank you so much for sharing it. So my question is more about the application you mentioned, like for example, for autonomous driving or humanoid robot. I think both applications are in the edge AI or embodied AI space, which means we run the AI model directly on the hardware, like this physical device. I'm just thinking how you think about the relationship between edge AI and the cloud AI, because or just how you see the trend of both directions and how they will grow. That's my first question. And then my second question is, a lot of times for the autonomous driving or humanoid robot, if we are going to run like large models on this physical device, then we definitely need a very high powerful or high performing GPU running these models. But like for other devices around us, for example, our mobile phone or AI PC, maybe it's battery powered and it doesn't have a lot of computational resources. So I'm wondering if you know any other applications besides these two, where we really need the AI models running on the edge device.
So I think that in many cases, my theory is that we will have the inference and other applications running more on these distributed edge devices. And then in terms of the amount of programming power, the hardware 3, hardware 4 systems in the Tesla vehicles, which are sufficient to run 12.5 and the current generation of models, those are about 20 trillion operations per second. So that is enough. Clearly, you can do better with a larger, more compute model. So they're talking about going to 10 times that compute with the AI5. So that'd be 200 trillion operations per second. But there's a scaling relationship between the inference and the size of the model and the compute that you need for it. If you spend more compute resources on the training side, you can squeeze down the resulting model to make it more efficient and smaller memory. So, and you can, if you do that with enough compute, you can get that where you don't sacrifice the performance. Obviously, you can just shrink the model and just sacrifice performance. But if you just, in theory, you could go up 10x on the compute side, you could, in theory, maybe get 3x smaller on your model size. So that's oversimplifying it, but there's work that you can do to make a more performant model fit into a smaller edge device. Tesla is planning to increase the number of parameters on their full self-driving system by about 5-10 times, but they're going to still have it run on hardware 3, which was introduced 5 years ago. But they are eventually going to go to hardware 4 and then to hardware 5. So there's a trade-off between those things. So it's not a clear, can it fit or not? If you try hard enough or smart enough, you can make it fit onto a smaller device. And also, if you look at what you need to do, and do I need to do everything? Can I, what is my actual necessary thing? I'm not sure if I answered the first part of your question.
Yeah, definitely. So I wonder if you know any industries, for example, these people really need the applications on the edge device instead of running it on the cloud.
I think there's reasons for speed of response. There's reasons for data privacy. People don't trust running it on the cloud. They want to have, they want to give their own data, especially business critical data, over to Amazon or Meta or something like that. They want to keep it to themselves. So, there's many business reasons to not do it on the cloud, and then there's technical reasons why, performance-wise, you would want to have a local solution. Okay. I think there's some other people with their hands up.
Oh, hi, Brian. This is Wenhui Li. Thank you very much for your talk. This is very insightful. I do have one follow-up for you is I would like to hear your thoughts or prediction on how the future workforce looks like. So because we can see that 1,000 jobs being evaluated whether it can be replaced by AI. I would like to know, how do you feel people should pivoting themselves, and any new category of job you see in the future?
So I think that we need to learn the new AI systems. That it's just like when people, the internet came along, email came along, that people need to learn and be comfortable with that. My uncle, sorry, last time I had to talk at MJA, he was a executive at a large insurance company. And then when email came along, he had his secretary write his emails and do that. And then other people help him with, spreadsheet and presentations. So not being able to adapt to the new technology is not good. The ultimate potential is that a vast majority of jobs could be replaced, much like the Industrial Revolution, where we went from 80, 90% agricultural worker to the new industries. But this could be a different beast. But I think that fully replacing people will take a bit longer in some cases, but just it'd be tough to say. Like you could choose to, not use it as much for, call centers. You can use it more for call centers, and those jobs could be replaced. You could use it for other jobs. So there are jobs which seem to be more at risk for being replaced, and people need to be aware of that. But whether you got your job loss from an AI replacement, or whether you're just unlucky in a company that went bankrupt or downsized, is irrelevant. That you'd have to manage your career. I think ultimately, if the superintelligence and the highly intensive AI future starts happening, the vast majority of jobs end up being being done by AI. So then it could become very difficult. High levels of unemployment could be achieved, could occur. But society needs to anticipate that. Big tech, Zuckerberg, Sam Altman, they're aware that this is a possibility that could happen, where a lot of unemployment could happen. Then society could change, where we have a universal basic robot thing, where the economics are that money is being generated by these systems, and then people have the funds to then do other things. So then what becomes valuable in that kind of world could be things like content creation, entertainment, being the first to do things, TikTok world, Facebook world, where people go onto social media and say, hey, I'm first on Mars or something like that. So, but this is something that won't be happening overnight. That it will take, a couple of decades, I think, to occur. But when any particular area gets impacted, is something that you have to monitor more closely. And it's just not that area, but like your company, your situation, your company that you work at could choose to, cut an area where you're working in. We don't need this many programmers because programming with the AI is 5 times more productive for the amount of programmers that we keep. So it's a company by company choice, but if it becomes that widespread, it needs to be something that is societally managed. But for us, the individuals, we just have to be as useful and productive as we can, also controlling what money that we're making. Like if we can make our own business a side hustle leveraging AI, then that's something that would be more protective. But learning as fast and as quickly as possible, and then also having some other revenue streams and anticipate what might be valuable, something to keep going. So it puts even more of focus on managing your career, knowing what's going to happen, because you can't necessarily depend upon other people to do the right thing, even though I think they should.
Yeah. Thank you. Thank you, Brian.
Mm-hmm.
Hi, Brian.
Yeah, go ahead.
Sorry, hi, can you hear me?
Yes, I can.
Oh, thank you so much for the overview. Your lecture has been very informative. I really appreciate it. I was wondering if you could talk more on the copyright lawsuits that are against the AI company right now. The top of my mind is the one by the New York Times, and how this relate to the flow of information. I think it's interesting that the internet kind of break down many of the barriers in sharing information. Could AI potentially like reverse some of that movement because people and organization will want to protect their intelligent access?
Right. So the New York Times has specific articles where they're very unique and they are able to find it put out word for word in some answers by a large language model. And that because the systems, even though they say they learned off of data that is not copyrighted, they either make mistakes or they're lying. That there is a lot of, visual images, like there was a visual image where it was two people playing soccer, and the logo of the photo source was being blurred out, right? But it was clearly still visible. So the people who make artwork, movies, video, they can see that the large language models, as they currently are plagiarism machines, right? Where they're taking what is other people have done. So part of making sure that people get compensated, there needs to be tracking to that, and there may need to be some general legal solution where some pool of money is devoted so that artists, creators can be compensated from systems that are taking over work and using their own work. That's a clear legal thing that I made something and you're stealing it from me using this software. So that's something that should be resolved in courts, and there should be a generalized solution that if we want these systems to learn and do that, then perhaps everyone needs to be compensated for that past work that they've done. Like not just, Reddit or X being compensated for OpenAI taking their data and their message board, something like that, but the people who have contributed to the message board, this large group should be compensated. So that it supports the argument of some kind of, again, taxation wealth transfer where a significant percent, 40%, 50% or more, goes to us who've built up civilization to this point, right? That, in business or other things that should be going to. But it's clearly a tricky thing about how exactly those mechanisms work, what's efficient, but in general, we have, if there's superintelligence that emerges from this, we have helped make that happen by being suppliers of the data to create that thing. So then people should be compensated for it. And it's also just stupid if people say, okay, we'll do an industrial revolution, the 90% of people who are doing agriculture, end up doing no actual industry, but then just unemployed. You're creating a pitchfork, situation where the mob, will come for the people who are making this happen. It would be so unfair to just ripe for social unrest. So so people should be compensated.
Okay, thank you.
So the next person wants to unmute, ask a question.
Hey, Brian, it's Peter here. Thank you for taking the question. I guess I just posted in chat. Great talk. But I wanted to know in this, I see a lot of great promises, but in some ways, the road getting there is often the challenge. So one aspect that I want to get your thoughts is, who is liable when things go wrong? Is it the LLMs, or is it the data provider for training these models, or is it the application that sits on top of the LLM API, or is it the ultimate service provider that takes this knowledge or information and interacts with end customers?
So it's case by case dependent as to who is responsible. In the case of the self-driving car, so Tesla has said that you're still driving the car, and so they have not taken liability for it, and you still need to supervise and monitor the vehicle. When there is no supervised, either in the car or remote, then in theory, if the accident occurs, it would be the company. The company would still likely be liable and still liable for a lawsuit, even if they said, okay, and there are lawsuits against Tesla where it's like, you're responsible for it and you have to do it, but then they say, okay, no, you're responsible. So then again, it's a case by case where that case goes and like, did that person actually have it turned on? Was it the system that failed? Just like if you have autopilot on an airplane that crashes the plane, did they turn it on? Where the negligence occurs? And you have to parse each of the situations. And then also, jurisdiction-wise, that it's only primarily the United States that's so litigious around these things. In other countries, it's less. And if there is liability to a company, it's less. So it's the overall, is the whole thing being made safer or not? So they'll have to track the safety. So the issues of when something goes wrong, what liability is appropriate to each place. Does that answer the question? Or do you have something more on that?
Yeah, I think that answers most of the question, but a related question is, we regulate airplane flying, we regulate direct people behind wheels in cars. They need to be licensed. Mm-hmm. And the cars have to be certified for safety, but the drivers have to be certified. I don't see the parallel in digital economy or in software. And the users are left to do whatever they want, and the developers are building whatever they need. There's no regulation in that. And now that these systems are hybrid, means that they're moving actuators, they're moving large hunks of metal, and potential damage is as significant as the two cases I listed. So this goes back to, I guess it's not who owns the fault, but what kind of system what kind of ecosystem change do you envision that actually would make it safer? Because I think AI adoption would go a lot farther and faster if we have these measures in place, just better testing, for example.
Right. So there needs to be a level of diligence. The example I would give today is that we just had the CrowdStrike problem, which was not, I don't think, AI based, where they had a supposedly improved driver that they pushed out to tens of millions, maybe 1 billion Microsoft Windows computers, and then it caused a boot loop where we create a blue screen of death, which requires then a manual in most cases. If you configure in some cases, you can still do it remotely to fix it, but oftentimes you need to have admin access manual to remove that driver. So even without AI, you had this massive problem with improper testing, right? So there's going to be lawsuits against CrowdStrike, probably lawsuits against Microsoft, and then it's going to go to, like airlines were knocked out and that kind of stuff. So these kind of things, you need to have the solution for the United States is a lot of lawsuits to companies, the deep pockets where the money is, and then for other countries, because this was a global situation, it will be, fines or other things, however else they assign that liability. So, but the whole thing is to avoid that. So there needs to be testing. So there's improper testing on IT systems in general, complex systems in general. And hopefully with AI, you would get better testing, but there needs to be, I'm not sure what standards would necessarily do it. There just needs to be the systems made where the errors don't occur. Like there used to be human operators of elevators, and then now there's not, but then the system is so safe and reliable that, it's a 1 in a trillion thing if anything was to occur. So we need to get to that level of safety. We just need to have more monitoring to create the safe operations and prevent the errors to begin with, as opposed to just trying to say, we want to regulate you to do it. It's like, make it work. That should be the general approach, and to have companies that are involved in the testing validation side to provide services that would create the automated systems to make sure that the proper testing and validation is done. Just like we have test suites and other tools now on the IT side, that needs to be made more robust. Which I also discussed that adversarial software, for testing the Go software. We thought it was better for years, and then it wasn't, right? That there was problems with it that were something that humans could exploit. We just didn't, because it was such a large space to search in, we didn't know. So we need to have adversarial software systems in the simulation of we do these massive simulations of the robots or software. We're putting into a virtual world and then doing that. So having that 1000x, million times more intensive thing to get the number of tests to make it happen. So we have to have an ongoing simulation suite to make sure that things are working, so we can catch those things. And we just need to also not assume that it would always work, but have the fail safes and the other aspects of it still work. One thing would be that for a robotaxi, if you have a voice system like a Grok built into your vehicle or OpenAI, you can still talk to it and say, hey, pull over. I don't feel comfortable with this thing. You can still have input from the person to the system to say, stop, pull over. This is a problem. You can still interact with it. That input from people needs to be there so that things don't go out of control. Any other questions on that?
Thank you.
Okay. I think we have another hand up. And we have some other messages in the chat. Can you send a chat for the last question earlier than 6:40? Okay, so I think we're going to end at 6:40, so about 5 more minutes. So we have a time for a last question, and then we can wrap up. So I think that's what we'll do. So I have one last question. If not, we'll arrange to get the decks out to exchange information, emails, etc.
Any last questions, anybody? Well, if not, I'd like to first of all thank Brian for such a wonderful, engaging talk, as always. I forgot to mention earlier, actually, Brian is one of our board members, and we will be running a series of webinars on the same topic by Brian. And the next one will be on October 18th. I think a lot of you were asking about the recording of this video, and it will be available. So please check onto our website, www.montejade.org, where we will be posting the video when it's available and also our next events. Thank you so much, Brian, and also, of course, thank for the audience for all your great questions. It really made the discussion come to life. Brian covered a lot of topics, right? And I personally learned a lot with the large language models, from large behavior models, all the way from how that drives self-driving cars, robotaxi, human bots, and how advanced hardware is critical to as part of this whole AI to drive the future. So thank you everybody for your attendance, and we'll see you next time. Thank you.